Cadets. My name is Kimberly Bryan, and today we will be learning about a lesson entitled Out of This World. We're going to have a lot of fun today, so let's get started. First and foremost, I want to talk about the standard that this lesson addresses. It's the Mississippi Career and College Readiness Standard for 8th grade, Evaluating Expressions, standard number 4. So let's get started, shall we? Have you ever wondered about the cosmos or the space beyond the planet Earth that we consider to be outer space? If so, then you're probably just like Travis. Travis was infatuated with the outer space, so much so that each night he would go outside and spend hours looking at the stars for a very long period of time. One day, Travis came up with a brilliant idea. He thought to himself, I got it. I will become an astronaut. So Travis began reading books about the solar system and planning his first mission to the moon. The first question that Travis has is, how long will the trip take? Travis' mother told him that astronauts have to spend a long time away from their families to go on their missions, so Travis became afraid. However, Travis was determined not to give up. Geez, these numbers are big. I wish I had a calculator, Travis thought to himself. Can you help Travis with this trip to the moon? First of all, Travis knows that the distance from Earth to the moon is 238,900 miles. Travis also knows that a space shuttle can fly at a rate of 17,500 miles per hour. Can you help Travis calculate how long it would take to go to the moon? Step 1. Since Travis has to perform operations with large numbers, can you think of a way to abbreviate or shorthand the numbers to make them easier to work with?
Okay, so we know that the numbers that we were given today by Travis were given in what we call standard form. Standard form is just a regular notation on how we write numbers. So we want to convert from standard form to scientific notation. So let's start with the first number. The first number was 238,900. So let's help Travis out by converting this number into scientific notation. The first thing you want to do is locate the decimal, which is at the end of the number. In order for it to be in scientific notation, the first factor must be between 1 and 9. So therefore, you must move your decimal so that the first factor is between 1 and 9. So we're going to move our decimal all the way between the 2 and our 3, and we're going to stop. And we're going to stop here because the remaining number would be 2.389. And now the zeros are considered to be insignificant, so you don't have to write that. So then you ask yourself, is this number between 1 and 10? So if we were to convert this to money, this would be about $2.40. And yes, that's between 1 and 9. So now you're not finished. You must place a times 10 in order for it to be in scientific notation. And then you're going to count how many times I moved the decimal. So that was 1, 2, 3, 4, 5. And I always like to say, since 238,900 was a big number, your exponent will be positive. But if it was a small number, your exponent would be negative. Another way would be to say, if you had to move your decimal to the left, your exponent would be positive. If you move your decimal to the right, your exponent would be negative. The second number we need to calculate is the rate of the space shuttle. The rate of the space shuttle is 17,500. So, in order to convert that into scientific notation, we're going to locate our decimal. And when you don't see a decimal, it's understood to be at the end of the number. And then we're going to move our decimal place all the way till you get to the first non-zero digit, which is the 1 and the 7, between the 1 and the 7. You don't want to put it in front of the 1, because then the number would be less than 1. So the number has to be between 1 and 10. All right, so you're going to rewrite the number, which is 1.75. Again, you can drop the zeros because those are considered to be insignificant digits. So that's 1 and 75 hundredths times 10. And I move my decimal 4 places. And the exponent will be positive because this is a large number considerably. All right, and so that's how you convert from standard to scientific notation.
Step 2. How can Travis figure out how long it would take for a trip to the moon?
We learn from science that the distance formula is distance equals rate times time. We do know our distance and we do know our rate, but what we don't know is the time. So in order to figure out the time, we would do inverse operations, and I'm just going to write IO here for inverse operations, and we're going to divide both sides by the rate. Therefore, to figure out how much time it would take him to travel to the moon, you would just simply divide the distance by the rate. So the distance in scientific notation was 2.389 times 10 to the 5th power divided by the rate, which was 1 and 75 hundredths times 10 to the 4th power. When you divide those two numbers, you get, if you round or approximation, be 1 and 36 hundredths, and then you place your times 10, and in order to divide in scientific notation, you simply subtract your two exponents. So that's 5 minus 4, which gives us 1. So the time it would take Travis to travel to the moon is 1 and 36 hundredths times 10 to the 1st power in scientific notation. Well, now let's convert that back to standard. In order to convert from scientific notation to standard, you simply look at your exponent. If it's positive, move your decimal to the right. If it's negative, move your decimal to the left. Since it's positive, we're going to move our decimal one space to the right, and we get 13.6. So it would take Travis 13.6 hours to travel one way to the moon.
Well, there you have it. Travis has solved the problem, and you were the number one agent in order to help him solve his problem. Thank you so much and for a job well done in learning about scientific notation. We look forward to hearing from you soon. Until then, bye bye, Space Cadets.